Welcome to LeetCode Solver. I am a LeetCode Solver. Today I am going to solve a problem in LeetCode coding challenge, 30-day coding challenge. And today we gonna solve the problem last stone weight. I'm gonna open the problem for the first time, and I'm gonna share my ideas and thoughts and how to solve this problem in real coding interviews. Yeah, let's go ahead. First of all, I'm going to read the problem. We have a collection of stones. Each stone has a positive integer weight. Okay. Each turn, we choose the two heaviest stones and smash them together. Suppose the stones have weights x and y, with x is less than or equals to y. Okay. The result of this smash is if x is equals to y, both stones are totally destroyed. Okay. If x is not equals to y, the stones of weight x is totally destroyed and the stone of y has new weight equals y minus x. Okay, y should be greater than. The stone of weight x is totally destroyed and the stone of white has now y minus x. Mhm. At the end, there is at most one stone left. Return the weight of the stone or 0 if there are no stones left. Awesome. Sounds interesting. Okay, in each steps we're gonna choose the heaviest stones. Nice. Okay, so for the given sample 274181, here we have to choose 7 and 8 in the first time, and both are not same, then the heaviest stones will destroy the smallest one. 7 will be destroyed totally, and the heaviest one will be turned into 8 minus 7, which is equals to 1. Okay, yes, as expected. 2 4, there will be three ones. Two ones were already there, and one was created just after the operation. Now we combine. Okay, now in the next steps, what happens is like we have to uh, take both 2 and 4, which are the heaviest one, and then after we have to turn these stones into one, which is 2. Yes, because 4 minus 2 is 2. And in the next steps, we'll pick up 2 and 1, and we'll produce another one, which is equals to 2 minus 1 equals to 1, 1, 1, 1. And in the next steps, we'll take both 1 and 1, both are same, so both of the stones will be destroyed, and the remaining is 1. So yeah, so we have to return the 1, which is the last, or we have to return 0 in case there was no stone left. Okay, nice. I understand the problem, and the stone's length is 30. Okay, and each stones may be heaviest is 1000, starting from 1. Okay, nice. So the first thought that came to my mind is like if we arrange stones array in ascending or in sorted order, then pick two heaviest ones and perform operations as mentioned. So this is my first thought. In each time we will have a kind of sorted order of the stones, and we will pick up the heaviest two and we will do the operations. Now each time after performing the operation, we are adding uh, new stones. In case x is not equals to y. So as mentioned in the problem statement, we are adding new students. After adding new students, the sorted order should also be maintained. So be maintained. If we keep on doing this, then finally whatever we have, uh, then we can keep on doing the same, and finally the array size, if it becomes 1, then we will have the answer. Or if it is like there is array size 2 and both stones have the same weight, then we have to return 0 in that case. So yeah, now the challenge is we have to maintain the sorted order even after performing operation, even after adding new x minus y minus x to the array, we have to maintain the sorted order. This is the challenge. Now, if the array was like, first of all, if we sort the array, then after, if we keep on doing this operation, then this is not feasible. Like to add to the array, uh, already sorted array. I mean, already sorted array. We have to insert the one which the position of that new one, like y minus x, could be anywhere in the array. Like if it is like kind of 10, uh, 20, uh, 10, and like 3, 2. Now, if we perform the operation, then the new value will be like 20 minus 10, and it is 10. So position of this in the sorted array is like in the first position. So this is the case, but there could be the array where the order may be anywhere. Like if we have something like array is like 4 and this is like 7 and this is like 10, then if we subtract both this, the new thing will be 4, and because the difference between them is 10 minus 7 is 3, so 3 will be inserted in the mid. So in our previous example it was inserted at the beginning, and now in this example it's inserted in the mid. So the position where the new y minus x new one will be inserted is not clearly defined. In such cases, like the sorted order of the array, like sorted array, is not helping us. So it is not kind of dynamically being sorted even if we insert it into the array, it at the beginning position or at the last position. So if we want to insert at the position where it should be sorted, then we have to iterate over the whole array, then the complexity would be much higher. So let's think about this, some kind of data structures which hold this array, uh, which hold the array in sorted manner even if we insert at any time. So we know that such data structure already exists, which is a set which sort the elements in the sorted order. Uh, but the problem with the set is it picks up the values without duplication. So another things that we can do with the play around is like we can maintain the set as well as the frequency using a map. This is one of the solution. Also what we can do is we can maintain a map itself, and based on the frequency we can play around. Now another things we can do is easy to do is priority queue. So if we have a priority queue which maintains the values in the order from um, decreasing order, like from 20, 10 kind of things. So even if we insert the new value, it will goes to the position where it should be. So priority queue data structures seems to be more suitable in this case. Even if we can solve it using other data structures as well. So I'm thinking about using priority queue. So the priority queue, the complexity would be n log n, where n is the size of the array, n is the size of given array, which is stone array. Then the priority queue will give us the complexity of n log n, because it maintains the tree-based data structures in its internally um, using heap. So the complexity would be n of log n. Now, um, while in each operation it performs the log n operation, so we are going to perform n insertion, so it will be n of log n, and this is a big O of n log n time complexity, and time complexity, and here we have to um, put every elements to the priority queue. So space complexity would be big O of n. Now let's start coding. So let me define the size of given array, student start size, and let me iterate over every elements in the array and put it into the priority queue. So let's define a priority queue then. Priority queue which contains integer values, say pq, or okay, pq. So I mean, in a coding interviews or here for the practice, we can define any variables, but in the production code the variables name should be considered based upon the operations we are performing. So for now I'm using pq. So let's insert into the priority queue pq dot push stones I. So we inserted every stones. Now we're gonna do the operations. Let's do the operations forever, but we will break based upon the conditions. So I prefer to do so. Now we can put the conditions over here. If pq dot size is 1, then we can just return pq dot pq dot top. Yep. Okay. Now if we have pq of size is 1, then we are returning. Otherwise we will definitely have a, let's say if we do not have a size, like if it is 0, then we will return 0 as defined in the program statement. Now we will definitely have a x and y. We can find the x and y. pq dot top, pq dot pop. We find out the first one and removing from the container, and we will find out the another one and remove from the container. And according to problem statement, if both are equal, then we have to destroy them. If both are not equal, if x is not equals, suppose y is the bigger one, say y, which is the first one, and x. So if y is not equals x, then we're gonna insert the difference. So pq dot push, we're gonna insert the difference, which is y minus x, y is the bigger one, and otherwise we will not inserting anything. We'll just repeat the same thing again. So we are just popping out two things and pushing another new value if both are not same, otherwise both will be destroyed. So the loop will continue again, and it will goes here, and if you find the size is 1, then it will definitely return the top element. Otherwise, if it the size is 0, then it will return the 0 as defined in the problem statement. Now everything is over here. So the situation when it comes here is if the definitely uh, there is no any cases for this, so we can simply run our code. Unknown error, unknown error. Then something went wrong. Let me copy the code first and refresh the page. We are down for maintenance, please come back later. Okay, why it should be down this time? LeetCode server are up now, and now we are going to submit this problem and see. First of all, let's run the problem solution, I mean. Okay, it's fine. Now let's try with different test case. Like as I mentioned before, we may try with this one and see what happens. One, yes. And let's try with the kernel case, which is like if both values are same, like 2 and 2, then it should return 0. Let's see. Yeah. And what else? What can be other kernel cases? 4, 3, 2. 4, 3, 2. What happens? First of all, 4 and 3 will be selected, and there will be 1. And second stage is 1 and 2. Both are selected, and 2 minus 1, 1. Yeah, it's same as before. One. Okay. Server are quite slow. Let's try with 150. Answer should be 50. Okay, nice. Let's submit the problem then. Wow, accepted. Nice. Now we can see more details over here. Runtime is 0 millisecond and memory use 5.9 megabyte. And what else? Yes. Regarding time and space complexity, I already mentioned. Yes. Okay, all right. This is my solution to the problem. Last stone weight. And if you have any query, any other solution, other approaches, which may be quite faster than this, like big O and maybe I don't know, maybe approach, because the first solution that came to my mind is this. So if you have any other solution, Any suggestion or any comment, please feel free to comment, and feel free to like and subscribe. And if you want to uh, see more videos like this is my first video. If you want to see the videos like this, me solving other problems as well. I already solved other problems, but I did not created videos. So if you want me to create videos for these problems as well, I'm going to publish other videos as well. Okay, thanks. Have a nice day.